Professor Panster. Thank you very much for your attention. Good afternoon, everyone. My name is Carlos Sedeno, and I will speak on behalf of my team, conformed by Caio Ponte, Colin Campare, and Richard Rojas and Neil Solomon. Our team's project is called FROG Robotics. FROG is an acronym which stands for Fantastic Robotic Omni-directional Ground Transport, where the words directional and transport are omitted from our acronym. The purpose of our project is to create a robot that is beneficial to the medical industry and as well with the elderly. Because of the challenging times humanity has been facing due to the COVID-19 pandemic, our team wanted to provide an active alternative to help the world fight back against the current situation and contribute to the future recovery. With that being said, I would like to introduce you to a robot called the UVD robot. According to an IEEE report written by Evan Ackerman, UVD's cost oscillates between $80,000 to $90,000, which is relatively affordable for the medical industry. The CEO of UVD Robots states that hundreds of these robots were sent to China when the initial COVID case was discovered in Wuhan. The UVD units, they sequentially use an integrated UV sterilization lab to disinfect the surfaces. UVC Cleanhouse is another company that offers multiple products in terms of UV labs. Their products are smaller and target smaller environments, resulting in a cheaper price. As you see, UV tech is embraced by consumers and the medical industry, which is why it gave us the idea to pursue an ambitious goal of developing our own robot. The ultimate goal is to be able to sell this lower than our competitors' cost. FROG is an omnidirectional robot that has a sterilization compartment which uses UVC lights to disinfect objects. Now I will show you how FROG was constructed and how it operates. The chassis was constructed out of 2020 aluminum profile. 4 structures of 39 and 4 of 19.75 centimeters were assembled using 90-degree connectors brackets to create a rectangular prism shape. The motors of choice are the Neverest 40, which require 12 volts to operate and provide 160 RPM. And to support the structures and the motors, custom motor brackets were designed and 3D printed. The microcontroller, which oversees all the functionalities of the robot, is the Arduino Mega. The Arduino communicates with the motor drivers by using pulse width modulation, which allows the driver to deliver an average voltage to regulate the velocity of the motors. At the same time, Arduino oversees the door mechanism, which was designed to allow the microcontroller and the user to know when it's safe to turn on the UVC lights. The microcontrollers and its peripherals are powered by an 18-volt 5-amp-hour Makita lithium-ion battery. Most of the peripherals, they operate at 12 volts, so a voltage regulator was connected to the battery. The voltage regulator powers the distribution board, which distributes power to the Arduino, the drivers, the motors, and the inverter used by the UVC lights. FROG is controlled by a web application interface that can be used on any smart device with access to a Chrome browser and Bluetooth. The Arduino is connected to a Bluetooth module, which serves as the link of the smart device and the Arduino. The user can then vary the velocity and direction of the robot by using the digital joystick, the slider. It has a voice control. It has a path timing feature or an accelerometer in case the smart device has any. So we can control it by tilting the device. Now I will show you some of the technical aspects of our design. This is a technical drawing used to create the motor housing, which looks like this. As you can see, the motor is inserted into the housing, and the 2 clamps here, they secure the bracket to the chassis to provide more stability. Another essential piece which was designed is the hub adapter. These adapters are essential to keep the wheels held to the motors. For the software, this matrix equation was used to calculate the velocity of each motor and to make the robot move in the desired direction. The vector on the left side of the equation is the rotational velocity of each motor, and the vector on the right side is the desired motion of the robot. And the Arduino receives X, Y, and rotational velocities from the app and uses the equation to calculate the velocities for each motor. In regards to the power, each motor draws a current of 1.16 amps, which is result in a total of 4.67 amps. The Arduino draws a current of 50 milliamps and the 4 drivers a current of 248 milliamps. This results in a total current draw of 4.96 amps, and the Makita battery provides 5 amp hour, which is enough to power a robot close to 1 hour. And in regards to the sterilization compartment, the sterilization compartment is made out of acrylic, and inside you will find the UVC lights with some custom holders designed to secure the lights. Now, it exists 3 types of ultraviolet lights. It's UVA, UVB, and UVC. UVA light is the least hazardous with a wavelength of 395 nanometers. And on the other side of the spectrum, we can find the UVC lights, whose wavelength is 280 nanometers. UVC lights are 1,000 times more efficient at killing bacteria than UVA. According to an article written by the Center of Radiological Research at Columbia University, UVC radiation efficiently sanitizes air, water, and non-porous surfaces by destroying the protein coating of the SARS coronavirus.
Less detail.
Yeah, now I would like to show you how it operates.
More movies, less detail.
The user can control the robot by using the manual controls in the app. You see, when the user puts their thumb on the joystick, the robot will move in the direction in which the joystick was moved. The robot can move up, down, left, right, and any angle in between. And the robot will move faster when the joystick is moved further and slower when it's not moved much. The slider is used to rotate the robot in either the left or right direction. And when the slider and joystick are used in conjunction, the robot can achieve more complicated motion. The application can control the robot using autonomous path planning. The user can go to the path planning page, select a starting point, an ending point, and then the user can add barriers to the map, which will indicate areas where the robot cannot travel. When the user hits the Find Path button, the shortest path between the ending point and starting point, while avoiding the walls, will be found. The user can then save the map, and then go to the control page, load the map, select the playback speed, and when they hit play, the robot will travel the short path which was created on the path planning page. The robot can be controlled using voice commands.
Front, 3, left, 3, backward, 2, right, 2.
The user simply speaks a series of commands which are recognized by the app, and then the robot is moved in the same directions of the commands which were said.
Now the sterilization compartment.
The application alerts the user when the door to the sterilization compartment is open. When the door is closed, the application gives the user the option to turn on the UV lights. When the UV lights are on, UVC is used to sterilize the contents of the compartment. As a safety precaution, when the door is open, the UV lights automatically turn off and alert the user that the door is open. When the door is closed, the user again gets the option to turn on the UV.
Yeah, and that's our project. Thank you very much for your attention.
That looks really great. And I think if I had one of the other vehicles, I might be scared of this vehicle, except that it would disinfect me. It wouldn't actually destroy me. But it's a great vehicle, and it's a great user interface. And thank you very much for showing that.
Awesome. Thank you. Thank you very much.
Well, that's our projects. Professor Uyer, wrap it up.
Yes. You are about to graduate. Best of luck to you all. I know more or less all of you. And I think that I'm very proud that you've grown up so much. I know you from EE 259. I know you from a lot of other undergraduate interactions as an advisor, etc. I'm totally impressed how you became professional engineers, and it's very, very impressive. You should all be proud.